Hey, let's solve this logic puzzle that I gave my students on the very first day of my discrete math class this semester. You have a deck of cards, and on one side is a letter, and on the other side is a number. And the box claims that if there's a vowel on one side, then the other side has to be an odd number. Now, they've been known to make mistakes, so we want to check this to see if it's true. Which of these four cards do we have to flip to make sure this statement is correct? Pause the video, maybe lock in your answer, because I'm going to tell you the answer is that we flip the middle two. Now, this surprises most people. I will say that most people in a class did not get this at first, because most people, and they've actually done psychological studies on this particular example, will feel the urge to flip that 3 because it's an odd number and because the statement has something to do with odd numbers. Now, everyone correctly gets that we have to flip E, because the statement definitely says if it's a vowel, then we have to have an odd number on the other side. But for that same reason, we have to flip over this 2, because we don't know what's on the other side. And if the other side was also E, then that would be a violation of the rule. We have to flip that over to make sure there isn't a vowel on the other side. Likewise, at the end here, like the 3, we could flip it, and if we found a vowel, that would be great. That's consistent with the rule. But if we found a consonant, that would also be consistent with the rule. The rule doesn't say that consonants have to have even numbers. If you're still not convinced, the issue might be that when you see an if-then statement, it's not saying that that's the only way that things can happen. For instance, if you live in California, then you live in the United States. That's completely true. But the other way around is not true, right? If you live in the US, you don't have to live in California. In fact, the way that usually unlocks this for people, and it worked with my students as well, is to change the if-then statement to some other thing that might sometimes be in question. For instance, if you're drinking alcohol, then you need to be at least 21 years old. For instance, say we're checking this if-then statement and we see someone drinking a lemonade, we see someone drinking a beer, we see someone who's 18 years old, and we see someone who's 40 years old. Who would we have to check to make sure we're satisfying the rule? We don't care about the two people on the ends, the 40-year-old and the lemonade drinker. It doesn't matter what they're drinking for this rule. But the person drinking a beer, we need to flip that card over to make sure they're over 21. And this person here who's 18, we have to flip that over to make sure that they're not drinking a beer. The video cycles back. See if you can see the connection with the original question.